Okay, so hopefully my recording will be clear for you guys. Okay, so when I'm looking at this problem right here, um, so this is in implicit form. It's not terribly hard to solve for y, but let's go ahead and try it using our regular implicit. Okay, so remember that what you have to do is that you always want to show that you're taking the derivative of both sides. Okay, so just watch. Remember that notation is really important. Okay, now when I'm over here, I'm going to use the product rule, not the chain rule, because I have two distinct functions. I've got y and I've got e to the x. It would be like the chain rule if it was like e to the y, or something like that. Okay, so I'm just thinking of fg prime plus f prime g. Okay, so f is y. I don't need a dy dx because all I did was just use that function. I didn't take the derivative of it. Okay, the derivative of e to the x is e to the x. Okay, now the derivative of y is 1 dy dx. Okay, and then I just write the e to the x, the g function. Okay, now 3 pi, be careful. Sometimes our eye looks at that and it sees pi as like a variable, and we want to say, oh, the derivative's 3. Remember that pi is just a number, so the derivative of 3 pi is 0. Okay, so now I'm going to put the e to the x in front of this one. It's just kind of a little more standard. Okay, and divide both sides by e to the x. And I'm going to get that, let's see, dy dx. You'll see that you start to do a lot of this in your head. These get like pretty good. Okay, so dy dx is equal to negative y. And again, watch that notation right there. Make sure you're putting in dy dx equals that. Okay, so let's look at one that has more product rule in it, some chain rule. Let's see what we got here. Okay, so let's say that we have to differentiate the cosine of xy. Now, I could put that xy in parentheses. I just like to be able to write it a lot of different ways. Just because if you always see it in parentheses and then some professor all of a sudden doesn't put it in parentheses, then people are lost. So that's why I want to make sure sometimes, that we do it all different ways, just so you get used to it. Okay, so I'm going to do d dx cosine xy equals d dx x plus 3y. Okay, so I can see here on this cosine xy, so the mommy function is just cosine of x, but inside we have an xy. So that tells me it's a chain rule. And the chain rule has a product rule in it because it has an xy. Okay, so let's kind of look at, we're going to start with a chain. Okay, so I'm going to say derivative of cosine is negative sine. And I'm going to leave the baby in. Okay, now I've got to do this right here, which is the product rule. So if I do fg prime plus f prime g. Okay, so I want you to think about, so I'm doing the chain rule, but the chain rule is going to require a product rule. Okay, so I'm going to put f g prime. Well, the derivative of y is dy dx. Okay, the derivative of x is just 1, and then I just write y. Okay, so that's the derivative of the left side. Okay, over here, the derivative of x is 1. The derivative of 3y is 3 dy dx. Okay, so now I'm going to work on getting all the dy dx's over on the left, everything else over on the right. So one thing, though, that I do have to watch out for is this right here. Like, I have to distribute that through. I'm trying to think if I could do it without distributing. No, I think it would be too ugly. Okay, so let's see. We have negative sine xy x. Okay, so this is a weird form, dy dx. So all I'm doing is going here, and then I'm going to go here. I'm going to move the y to the front, and then sine xy. And I don't know why all of a sudden I decided that I wanted to put those in parentheses, but I did. Okay, so let's get dy dx on one side, everything else on the other. Okay, so this, I'm just going to move this x to the front. So I have negative x sine xy, I don't need the parentheses, dy dx. I'm going to move this guy over here. So minus 3 dy dx. I'm going to leave the 1, and I'm going to move that guy over there. Okay, now I'm going to factor out dy dx. And let's see if you're okay with, I'm going to factor and I'm going to divide. So I'm going to skip that step right now. Y sine xy divided by negative x sine xy minus 3. Okay, so I distributed, or I factored it out, and then I divided by what was left there. Okay? So we had a chain rule, or a product rule inside of a chain rule. All right, let's look at another one. And just the more of these we do, we just get better at derivatives in general. Okay, so let's say that we had the natural log of xy. Okay, so I can see this is a chain rule. If it said natural log of x times natural log of y, that would be the product rule. But it's the natural log of x times y. Okay, so let's do d dx, natural log of xy equals d dx sine x. Okay, so the mother function is the natural log of x. Well, the derivative of natural log of x would be 1 over x, but we have to leave the baby in. Okay, 1 over xy, but now we have to differentiate the baby. Okay, so when we differentiate the baby, we got to do, not the chain rule, we already did the chain, we're going to do the product rule. Okay, so if I go fg prime plus f prime g. So I'm going to do x derivative of y dy dx plus f prime derivative of x is 1 times g. Okay, so we got that guy taken care of right there. Okay, equals the derivative of sine x cosine x. Okay, let's see what the heck we got going here. So we have, oops, I should keep this in parentheses here. Okay, so we have x over xy dy dx plus y over xy is the cosine of x. Okay, so let's see what happens there. Okay, so that cancels out. So 1 over y dy dx, those cancel out. Oops, plus 1 over x is equal to the cosine of x. Okay, 1 over y dy dx is equal to cosine of x minus 1 over x. And then I want to get rid of that 1 over y. I'm just going to multiply by the reciprocal. Okay, so it's like I'm just doing that. So that dy dx is equal to y times the cosine of x minus 1 over x. And that is our answer. Okay, let me stop this one here.